Hello guys. So we were solving 2D dynamic problems, and today we will be solving this last problem from the 2D dynamic part. From tomorrow we can start from the greedy part. So okay, so there are only medium questions in the greedy part, and okay, we have also intervals, math and geometry, and bit manipulation. Okay, so let's solve this problem. Burst balloons. Okay, so let's read out the problem. So the problem says you are given n balloons indexed from 0 to n minus 1. Each balloon is painted with a number on it represented by nums. Okay, so these are the n balloons, and this is the number on the balloon, on the ith balloon. You are asked to burst the balloons. Okay, we need to burst the balloons. If you burst the ith balloon, you will get this much coins. Okay, if we burst this coin, so we get total coins, uh, this into this means the current number of coins and the coins on the left and coins on the right, so all these multiplied give us the number of the coins we get if we burst the ith balloon. Okay, if I minus 1 and I plus 1 plus 1 goes out of bound of the array, then treat it as if there is a balloon with a 1 painted on it. Okay, so basically let's suppose we burst this balloon 3, then I minus 1 is going out of bound, so we can take 1 on the left of 3. Similarly for 8 we can take a 1 on the right of the 8. Okay, okay, so output for this particular case is 167. So how it's 167 means what we need to return is maximum coins we can collect by bursting the balloons wisely. Okay, means we need to burst the balloon in a order that gives us the maximum coins. Okay, so the example is we are given this coin. Okay, these coins, so first we are bursting coin 1. Okay, so this is the number of coins we get, means if we bursting 1 we get 3 into 1 into 5. Okay, so this much coins, so now we don't have 1. Now we are bursting 5. Okay, so we get 3 into 5 into 8. Okay, so now we don't have 5. Okay, then we burst 8. Sorry, then we bursting 3. So on the left of 3 we have nothing, so we are taking 1. Then we are bursting 8, so left and right. Okay, so 167 is the answer, means at last we will burst 8. Okay, similarly for this we are getting 10. So our constraints are this. Okay. So acceptance rate is 60%. So I think two type of questions has a high acceptance rate. One which are really easy and second one which are really hard. Only question which seem to be easy but are actually hard has a lower acceptance rate. Okay. So how we can solve this problem? Suppose we burst this balloon 1 initially. So means here we are changing the input array, means we don't need to change the input array, means changing the input array will be a bit complex and it will also be a changing variable in our recursive call, so we can't memorize it. So we need to think of a way where we don't need to modify our current array. Let's say we have this particular string, this balloon. So suppose now we want to, so we have busted balloon 1 and we will add to our cost 3 into 1 into 5. Okay, now we need to as we have busted this particular balloon, now we want to solve the problem for the balloons on the left and balloons on the right, because we are only left with the left balloons and right balloons. Okay, let's say we have a one more balloon 10. Okay, if we busted the balloon 3 and sorry 1 and we have a initial cost this. Okay, so now we need to solve it for right position and left position. Okay, uh, let's say now we decide to solve this problem for this balloon 5. Okay, we are trying to burst this balloon. So in the left as 1 is already busted, means the left of the 5 is busted, so we need to consider left as the 3 now, because we have busted the balloon 1, and on the right we will be having 8. Okay, but how we can store that, we can know that what is in the left of 5 at a given instance if we decide not to modify this our array? let's say we have busted these two balloons simultaneously. Now we need to bust the eight. So we have busted these two balloons and we want to burst eight. So on the left of the eight is three, but how we can know that? Okay. So basically, what we can do is means we cannot do like this. Let's say we have this array. Okay. So what we have done here is we have this balloon. Initial at the last we have balloon 8. At the end we have balloon 8. Okay. So what possibly we have done here is on the left of the 8 is 1 and right of the 8 is 1. Okay. Going before it okay, so on the left of the 8 is 1 and right of the 8 is 1. So one thing we can say is if we have busted 8 at the last, so suppose we have this array and we have busted 8 at the last, so what we can say is the elements we busted before 8, as we are busting 8 at the last, so the balloons which we are busting before 8 will have uh, 8 as their right value. Means if we are busting this particular sub array, means sub array, so 8 will always be present because let's say we are busting 8 at the last, so for this particular array, for this 5, the 8 will always be right because we are not busting 8 currently, we will be busting it at last. So means 5 5's right will be 8. Okay. And okay, and the 8's right will be 1. Okay. So let's say from here we can say is if we are busting it at the last, so we will be having for this particular subarray 8 as the right. For 3, why we are having 8 as the right? Because we are busting 8 at the last, so for 3 we are having 8 at the right. So now the 3 will be left of 5 because 3 is left of 5 because we are busting 3 we are busting 5 before 3, we are bursting 5 before 3. We are bursting 5 before 3, so when bursting 5 we will be left with 3. Okay, so that's why 5's left will always be 3 for this particular example. So now we have these 3 balloons left, means we haven't busted these 3 balloons yet, but we have busted the balloon 1. That's why that balloon is not present here. So for 1 what we can say is the left will be 3 and right will be 5, because they are not busted. So what I mean to say is, going backward we can say that, uh, means suppose we are deciding to burst this balloon at the last, so this balloon will be present for all the balloons before it. If we are bursting 8 at the last, so it will be present in all the calls before it, because it will be present on the right of all the elements. And as we are bursting 8 at the last, so it will have nothing on its left and nothing on its right, so we are taking 1 as the value on the left and the right. Okay, and as we have 3 here, so we can say is 3 is present, and all the values apart from these two values are already busted before, so we can say that the right of the 3 is 8, and the on the left we have nothing, so left is the 1. Okay, so what I'm saying is, suppose we bust the balloon 8. Okay, so let's say we have, suppose we are bursting balloon 8 at the last, so 8 1 into 8 into 1, okay, will be the value we have. So we are bursting it at last, so let's say now we move to these elements, we try to burst these elements. Okay, so we are bursting it at last, so now we are deciding to burst the 3. So as we know, we have busted all the elements and we are only left with the 8. So what we will be doing is, we will be now I can take this same array. Now we will be bursting 3, so on the left of the 3 we have 1 and 3, and on the right we will be having 8. Okay, means here we are taking, for this particular example we are having our left part as this. sorry, right part as this and left part as this, which is out of bound. And for 3, what we are having left part as this and right part as 8. Okay, because 8 is present, we will be busting 8 after 3, means we are actually starting from the last, means first at last we are busting 8. So before busting 8, uh, we have 8 will be present in our array. So let's say suppose we bust the 3. Now the left of the 3 will be this and right as 8 is present this. Okay, so let's write down the array again. 5 and 8 is present and 10. So now what we are doing here is we are deciding to bust the fifth balloon. So suppose we decide to burst the fifth balloon. So for this particular balloon, as we are bursting 3 after it and 8 after it, at the right we are present with the 8 and at the left we are present with the 3, because we are bursting these balloon after 5. Okay, so what I am saying is come on. Let's call this as the length. Then we call a function find max coins. We are at 0th index and minus 1th index. So this is our array is bound. Okay, so public find max coins int nums array int left part int right part. Okay, okay, so initially suppose we are bursting 8, so left part is this and right part is this. Okay, that means right part is n and left part is minus 1. Means for the last balloon, suppose we're busting 3, whatever balloon we are busting at last, we will be having the left and right values out of bound, because we will be left with only one balloon. So the left values will be out of bound, means we have to take the 1. Okay, so base condition will be like if my left part passes the right part, in that case I can return, let's say, 0 for now. So we have to burst one of the balloons. So okay, so we have to burst one of these balloons. So let's take 0 and n minus 1 here. Okay, so int I is equals to left, I less than equal to r, I plus plus, means we are bursting ith balloon. So cost will be, let's call cost as the nums of I. So we cost will be nums of I, nums of I minus 1 and nums of I plus 1 basically. But let's say we are, what we are doing is we are bursting the 8th balloon, means we are bursting the first balloon we have. And after that what we are doing, we are we know that we are bursting 8 at the last, so element which we are bursting after the 8 means 8 will be right of that, means for the elements which are present on the left of the 8, for that 8 will be their right, and elements for which are present on the right of 8, for that elements 8 will be left. So means that means we have two bounds. The left bound will be L2R minus 1, and right bound will be R plus 1 to, sorry, I minus 1, and right will be I plus 1 to R. Okay, so that will be the right bound. Okay, so what can be our cost? It can be the cost of this part and our current cost, and cost of the right part, I plus 1, and this is the ith cost. Let's say we have a total cost of integer dot minimum value. We need to maximize the cost, so total cost will be math dot maximum of total cost and this value, and we will be returning total cost at the end. But we are not handling the case when we have nothing on the left. Okay, we initially have at last we burst 8, so there will be nothing on left and right. Okay, but for this case I will become plus 1. Suppose we have these two values, 4 and 8. First we burst the 8 value. Okay, so what we need to do is our current cost will be this cost plus let's say if L equals to minus 1, in that case it will be 1, otherwise it will be nums of left. Let's say if our r becomes equal to the n, okay, let's pass them minus 1 and n, then in that case it's 1, otherwise it's nums of r. Okay, means what we are doing, for 8 we have nothing on the left and nothing on the right, so that means L will be minus 1. We are computing the current cost as this. Okay, and the total cost will be this cost plus the left cost and the right cost. Okay, but this is causing us issue here, because if we are taking L as the left element, can we do like this? Means we ignore these indexes? Or we can pass 0 and minus 1, start from L and 0. If L minus 1 equals to minus 1, then we can return this one, otherwise we can return value. If R plus 1 becomes n, otherwise I can return this value. That way my index will also obey the rule. Okay, and the cost will now be the current cost which I have calculated, and the cost on the left part and the cost on the right part. Suppose we have 4 and 8, so if we burst 8 at the end, that means at the end we are left with, on the left of the 8 we have only 1, on the right we have only 1. So we pass 0 and n minus 1, and suppose our I reaches 1, we take 8, and on the left of the 8 we have nothing, on the right we have nothing. Then we pass this value 0 0 0 to our call. This will be 0 0, and this will be this is 1, this is 1, this will be 2, so 2 and 1. Okay, so this will return 0, right cost will return 0, and what left cost will return, it is 0 and 0, so it will run for 0, nums of 0, and as the right we are passing I minus 1, so basically 0 0. So as the right value r plus 1, we will be taking 8 as the right value. Okay, so it will be giving correct cost. So let's run this. Okay, it should be int. Okay, so I think the logic is correct. So I have actually gone through where's this gone through this particular topic on introduction of algorithms, which is matrix chain multiplication. So basically this is the same problem where we multiply the matrices, and our goal is to reduce the cost of multiplication of the matrices. So it's the same question, means in matrix chain multiplication what we do, basically suppose we have this particular array 4 and 5. So what we do is we assume that we have a matrix of 4 into 5, suppose 6. Okay, so 4 into 5 and 5 into 6. So we can only multiply matrices if their rows and columns are equal. So basically this problem is to find the minimum cost, to find the minimum number of multiplications we have to do. So here we have to do 4 into 5 into 6 scalar multiplications to multiply these two matrices, or matrices of these sizes. So the order in which we multiply the matrices actually decides that, means the cost can be different for the different order of the matrices. If we follow different order for the multiplication, there will be different cost. So basically the way, for example, here we have a matrix, two matrices. How many matrices we have? Three matrices. First is 10 into 100, then 100 into 5, then 5 into 50. So if we multiply matrices like this, first we multiply a1 a2. Okay, then that means 10 into 100 into 5. Okay, that means 5000 scalar multiplication. Then we multiply the result of these two matrices to this matrix, the scalar to compute the plus another, then another this much. So total cost will be this. Okay, but if we change the order, suppose we multiply a1 and a2 first, these two matrices first, then at the end our cost is 75,000 multiplications we need to do. So basically we need, that's the same problem. So this is the algorithm which we are implementing. I think this is the tabular way. If you are free, then you can go through this, otherwise you can follow any other video on YouTube. So let's memorize this. So our these two variables are changing, so we can memorize our array for these two variables. We can means create DP for these two variables. We are creating for these two variables. So we will check if we have already calculated this particular problem already. Otherwise we will store answer for this particular problem. Okay, so this was the matrix chain multiplication problem, basically bursting balloons. We will be having some similar problem also. Minimum cost to merge stone. I think this will be same as the burst balloon problems, means using matrix chain multiplication concept. Okay, so thank you.